Okay, question 17, 18, and 19. I'm going to show you how to use a graphing calculator to do these. We need to get x-intercepts and the vertex. There's more than one, we'll separate it. And we can do this all. Now, there's ways they give you formula in Alex, and you can follow those, but with a graphing calculator, we can also do this. Let's see if I can move this over. Here we go. Okay, so let's execute. Let's go here. Let's clear these guys out. Okay, x squared. Arrow over so that you're in the place to put in subtract 4x and then subtract 12. Now there's not a second equation because this is just y equals, it's a function. Let's go to the window. Let's see, shift, oops. Let's not put that in. Let's go to the window. Oh no, I don't want that. Oh, I have to execute. I forgot. Do that, and then let's go to. You could well, let's just go to draw. Let's see what we see. Yeah, see, we don't see enough. We see one of the x-intercepts, but so I'm going to go to vertical window or V window. I'm not quite sure what the V stands for. View window. Okay, what do we want to view? Let's just go to the standard. Here's a quick way to do that. And then let's execute and draw again. See if we see. So we do see these two things. We don't see the vertex, so we want to go down a little bit more. So we'll go to the vertical window. That's the y minimum. It's only going down to -10. Let's go to maybe -30 to make sure we can see enough. And then we draw it again. Yeah, we can now see the vertex. We can see the two x-intercepts. So this is also, we're going to use the G-solve tools. Graphical Solve is my best guess. We want the x-intercepts are called roots because that's where it kind of goes through the ground, right? So we're going to look for the roots, and it's beautiful the way it just finds it. X, -2, 0, right? Because that's the thing is, these could also be called zeros, but x-intercepts. Okay, -2 is one of them. Again, they don't really say the formatting. Do they want them as ordered pairs or not? But then when I hit the right arrow, it will go find the other one, and that's at 6. So those are your x-intercepts. Your vertex. Find the x-intercepts. So those are your x-intercepts and the coordinates of the vertex. When I say coordinates, that's an ordered pair, so we're going to need it enclosed like this. And what we do for that is notice it doesn't, we go to Graphical Solve, doesn't say vertex, but what we have here is we've got a minimum value. So that's what when we find the minimum value in this window, we're going to have the vertex. If it was going the other way, if it was opening downwards, we'd go for the max. But it's not, so we go to the minimum and it just finds it for us, and our coordinates are 2, -16. 2, -16. That's all we need. Let's go ahead and continue on this with number 18. Again, we've got a lot of stuff here, but what we've got is a function. I always see this first. Okay, that's pretty, 33,000. That's huge. What is the minimum unit cost? So vehicle factory manufactured cars. Cost unit, cost in dollars, depends on the number of cars made. Okay, so X is number of cars made. If X cars are made, then the unit cost is given by this function. So this is the cost per car. It's a $33,000 car, sort of. We'll see, depending on how many you make. Do not round your answer. So what is the minimum cost? So we're going to graph this, and then we're going to find its vertex, because a cost function probably is going to look like this. And, if you produce this many cars, you get a minimum cost, and then the costs start going up because you have to least new space or something. I don't know. Anyway, now you could also find the x-coordinate of the vertex using the vertex formula, which is minus b over 2a. Okay, so you'll see that works as well. But let's just do it graphically with these tools. So we go to, let's see, oh, that's strange. I didn't know that could happen. We're going to take out this function. We'll put in 0.4 x squared. So the x squared works too, so whichever way you want. And then it comes back down. That's kind of cool. Glad I did that. That was a mistake, but sometimes you find your best things by making mistakes. Plus 33,821. Now, before we do this, we know that this is opening upwards because this is positive, and sort of we've got to be up in the 33,000s. Because watch, we're going to graph this, but we're not going to see anything. We're not even up. It's like way top of the sky. So we go to our vertical window, and what we want is y max, right? Where are we? What's going on here? X. That's all of this stuff. Oh, it's on like a trig. Let's go to standard, I guess, first, and then y max. Let's like make it 50. I don't know, 50,000, 40,000, 45,000, so we can see up high enough. Now, when we graph it, let's see what we see. Okay. So, and again, the other thing is our x values aren't being very helpful here. We don't see enough, so we got to think we're producing cars. So let's come back to this vertical window. We really don't need to worry about negative cars being produced. We can make that into 0. And then how many cars do you think a factory is going to produce? I don't know. Let's go with 500 cars. And then let's just see what we see. It's enough. If it wasn't, we'd make it more. If we only went to 50, we might only see to here. And so we play this game until we can see what we need to see. Okay, that's the mathematics of it. We can see the minimum. We just have our graphing solve tell us what that minimum is. It's 240 cars. And of course, you can't round your answer anyway because there is no rounding. So what is the minimum unit cost? So the cost is the y value. The 240 cars, if we produce 240 cars, then it actually only costs us 10,781. 10,781 to produce that car, to produce each car. That's the unit cost. So when like here, you put in zeros for x. The first car, it's very expensive, 33,000 to make. But as we make more, we get what do they call that in economics? They get scale, something of scale, economics of scale. The more you produce, the costs come down until maybe the costs start going up, at least according to this model. Okay, so but just be careful. That's the unit cost. Cost is the output, 10,781. All right. And let's just go to this last one. We're going through all of these at the same time. 19, find the zeros. Again, you could set each of these equal to 0 and find them manually. What I'm going to do is I'm going to show you there's going to be this, when x is 0, we're going to get a 0. This is we're going to see, because you would actually, x minus 16, so at positive 16 we'll get a 0. Actually, we'll get a double 0. We'll see what that looks like. And at positive 3, we're going to get another double 0. Okay, and when double zeros happen, what you get is one way or the other. That's where it just touches the graph. So we're going to see something like that. And again, I can see that's going to happen at positive 16, positive 3, and at 0. Those are going to be where we've got them. And again, you could get that from setting each of these equal to 0, right? You say 5x equals 0, x minus 16 equals 0, and x minus 3 equals 0. And then add, so you get x equals 3, x equals 16, and in this case x equals 0. Divide both sides by 5. So we're going to see that. I'm going to show you. You can verify it with the graphing calculator. Okay, so we go to here. We put in our function 5x parentheses x minus 16. And it's nice thing about this, if we ever get stuck, we can, because we get something different and we're not quite sure, we can just graph it. Of course, understanding what we're doing helps us to get our window sized. So it's kind of one of these catch-22. It's just the graphing calculator does not do everything for us. It's only a tool to help us see things. So we go here, remembering our window's all whacked out. I'm going to go to the window first, and I'm going to go to a standard. Kind of gets us negative 10 to 10, negative 10 to 10. I'm looking here, I see 16 is going to be one of my zeros, so I better make my x max bigger than 16. I'll go to 20, and I think I'll be just fine that way. Y's I'm not sure about, so we'll just do that. Hit execute again, and now let's draw it, and let's see. What do we see? What did I do? There should be something else happening here. Let's see. 5x, x minus 16 squared, x minus 3 squared, okay, so, well, let's do this. Let's try this. Might be my window. Let's zoom out a little bit, I guess. I don't. Sometimes we need to zoom in, but I think with this thing just might be getting really big. Let's go 100 to 100. Zoom out. If I don't see anything, then I'm going to zoom in. That's how I'll do this. Okay. Yeah, okay, they're coming. So let's do this. This is a weird looking graph. So I see that kind of the 16. This is coming close. Sometimes they make it hard. So let's go for graphical solve. Let's go for this. Let's look for roots. This is the cool part. There's 1, x equals 0. Watch. Is that all it's going to find? That's all it's going to find, huh? Should find 1 at 3 and negative 16 as well. I don't know. Maybe I'll have to do the drawing board on this one. Did I do something wrong here? Let's let me delete this and try it one more time. Maybe I need to go to something like times x minus 16 raised to the second power, and then we go times x minus 3 raised to the second power. No, it's still doing this sort of thing. I think it's just so steep it's not finding it. Sometimes the graphing tools just aren't going to help us, aren't going to be our friends because of how this is working. But yes, see, if you put a 16 in here, you get 0. Once you get 0, 0 squared is still 0, and then the whole thing becomes 0. So technology just couldn't keep up with what's actually happening. So this one we just found. There's our answers. That's all we can do. Thank you all.